Now let's focus on geometry as a math domain. Geometry translates as the measure of Earth that involves the measuring and moving objects in location and space. It is the foundation of mathematics and was developed to figure out many everyday problems. How do these pictures relate to geometry? Think for a moment about the skills involved in these different activities. Someone solving a puzzle, reading a map, trying to locate a place, building shapes in Minecraft, navigating the seas, and constructing a birdhouse. Is one of these easy for you to do? Or do you think you can learn to do it easily? Consider your own beliefs concerning an individual's abilities in the area of spatial sense. What do you think causes some people to have better spatial reasoning than others? Some people believe you are born with spatial sense. This is not true. Meaningful experiences with shapes and spatial relationships, when provided consistently over time, can and do develop spatial reasoning and thinking. Geometric knowledge seems to be a universal capability of the human mind. Research has shown a connection between a student's ability to reason spatially and their overall math performance. Here's a definition of spatial reasoning. It involves the location and movement of objects and ourselves, either mentally or physically, in space. It is not a single ability or process, but actually refers to a considerable number of concepts, tools, and processes. This connection to different math number concepts and arithmetic skills makes it an essential topic for all grade levels. Geometric and spatial thinking connect mathematics with the physical world and brings the non-physical world to life through modeling. You can see this in the many ways in which we use these ideas. As we see, geometry should not be the unit that we might not get to at the end of the year. It plays a major role in the mathematical content, the physical sciences, engineering, artistic connections, and many other subjects. Here are the main topics that make up the study of geometry for grades 3 through 5. Visualization, shapes and properties, transformation with a focus on symmetrical reflections and location. As you can see, it is so much more than learning the names and memorizing the attributes of shapes. Take a few minutes to read about each one. Press pause when you're ready to continue. These content areas overlap and build on each other. The following slides present different activities, but you may adapt them for different purposes, depending on the focus of your grade level. Students should have rich experiences in K2 drawing shapes and freely exploring how shapes fit together to compose larger shapes, and how larger shapes can be taken apart or decomposed into smaller shapes, such as making pictures and designs. These shapes of activities involve informal geometric problem solving, allowing students to develop ideas and relationships. The progression document states, there is a suggestive evidence that this type of composition corresponds with and may support children's ability to compose and decompose numbers. This connects the important role of visual models to number and measurement concepts. There are many tools students can use to explore, talk about, and interact with shapes, pattern blocks, geoboards, tangrams, and several virtual manipulatives. Their description of how the shapes look may use informal language, such as curvy, pointy, and skinny. And when the orientation of the shape changes, the shape's identification changes, such as a square turns into a diamond when it's tilted. But by the second grade, students should learn to name and describe two-dimensional shapes attending to the number of sides. One activity we can use with students is to develop their geometric ideas is Guess My Rule. This activity allows students to use their own informal ideas and definitions in describing shapes. As the class discusses the students' ideas, the teacher may guide the class to a more refined and conventional definition of shapes. Let's play. I have a rule in mind, and all these blue shapes have this rule in common. None of the yellow shapes follows my rule. Note, this is providing non-examples of my rule. So which of these green shapes follows my rule? Press play when you're ready to have me tell you. Did you guess a four-sided shape with all equal sides, or a quadrilateral with four congruent sides? One way to play is not to provide non-examples, but rather let the students guess which shapes do not follow the rule. As you tell them yes or no, they figure out which shapes belong in the group and which do not, and begin to figure out why. You can encourage this type of thinking by asking the questions, what properties do the shapes share? This activity is more than just memorizing the attributes of shapes. It helps students understand how shapes can be classified and subclassified. Students are beginning to form ideas about larger superordinate categories. They see all four-sided shapes as quadrilaterals and recognize that all quadrilaterals include other categories, such as trapezoids and parallelograms. In fourth grade, students explore symmetry, as this is the introduction to an advanced topic, reflection, as a type of transformation. Again, it's important that students have a multitude of experiences, not only a worksheet that asks students to draw a line of symmetry through a particular shape. Students can construct the other half of an image so that the whole image is symmetrical, as seen here. And they can use different tools to do so. Cutting out a shape along a paper fold line reinforces the concept of symmetry. The fold line is a line of reflection. The shape on one side of the paper is reflected on the other side. Again, the bigger idea is that line symmetry is a part of transformations due to its connection to reflections. I'm providing this as a foundation to the middle school standards. Here are some resources for you to explore. Quadrilaterals. For students to understand the classification of shapes, teachers have to provide meaningful experiences to students. This activity helps students connect the shapes to specific geometric definitions, including types of angles and parallel and perpendicular lines. Assign each group of students a category of shapes: squares, parallelogram, rhombuses, and rectangles. Have the groups identify as many properties as they can under the headings sides, angles, lines of symmetry. Encourage them to use the words exactly, only, at least when describing these properties. Let's think about parallelograms. How would you describe the angles? At least 4 angles? Are there always right angles? Are there opposite angles congruent? What about the sides? Are the opposite sides the same length? Are they parallel? How many lines of symmetry does a parallelogram have? As they share their lists, the class will compare definitions for the shapes, refining their vocabulary throughout the discussion. Students can explore which of the shapes are subcategories of other shapes and why. These types of activities build a foundation for students to create mental images associated with the definitions. For example, they start to mentally see right angles as having 90 degrees and performing perpendicular lines. Here's an activity that I used to love doing in my classroom. Again, the emphasis is on students developing an understanding on how certain attributes, in this case lines and angles, interact and relate with each other in possible and impossible ways. Take a few minutes and try it yourself. Press play when you're ready to start again. Which types of triangles are possible or impossible to draw? What did you learn about triangles? How does this type of activity lend itself to classroom discussions of what is always true, sometimes true, or never true? My students enjoyed proving and disproving their ideas to one another by using their knowledge of the attributes and vocabulary. Again, the focus is not memorization, but on understanding the relationships among these classifications. Next, you're going to see a video showing a fourth grade student engage in discussing their ideas about classifying triangles.
So that's what we talked about last week. I think our visitors now have an idea of what we did last week. So now we're going to move on. So do you remember also when I left, I gave you a task where you had that grid and you had to place those 3 triangles and figure out where each of the triangles went? You remember that? So one of the triangles you had looked like this. And we had some of you, before you say anything, I just want you to quietly look as I'm placing these. I'm going to place 3 of these. So I want you to think about where I'm placing them in 3 different boxes on this grid, because we had different answers for where you thought this triangle went. Just silently, just think. You can think it as hard as you want. Just don't let it come out your mouth right now. I'm going to place these 3 triangles on this grid, and I want you to think about that answer and what that student was thinking. What did they know about this triangle, and what did they maybe mix up or misunderstand about this triangle? Does that make sense? Do you have any questions? Okay, so you're not going to talk for this part. You're just going to look at it and decide for yourself. You will talk in a minute, but we're going to be silent at first. And I know my triangles are too big for the boxes, but I think you get the idea. So for each of those places, what did the student understand? And what, if anything, did they get mixed up? Hang on, I'm not taking hands yet. All right, why don't you turn and talk to your partner about what you think they understood?
He got mixed up of where it goes, but he's correct about the angle is see, he knows that there's a right angle, so it goes there, but he got mixed up on the placement. Really cool rabbits like isosceles and scaling.
So I think what they mixed up is they mixed up that scaling all 3 sides are different. I think that scaling, they are all right angles, but the problem is that they just put them in different things when they're supposed to go in one.
Yeah, because they all are like the same triangle. Yeah, but
I think that they are.
but I think they're the same triangle.
I think
What do you think about the placement of these triangles? So, and I'm going to ask you, when you respond, just talk about one triangle at a time. What do you think they understood? What do you think they misunderstood? And I haven't heard from Nico yet. Nico, what do you think?
I think we got mixed up on the fact that the isosceles triangle should have one different side, not all of them should be different.
Okay, so for isosceles, you're talking about this one? That they got mixed up. Say that one more time.
They got mixed up with the isosceles triangle should have only 2 sides that are the same and one side different, except what he thought or she thought was that they were all different. That's what an isosceles triangle was.
And they thought that all the sides were different and it should be 2 sides of the same. Okay. Did you have, I can't see your name tag. Marina, did you have something to add to what Nico said?
Student didn't understand that they were right angle, but he didn't understand that it was an isosceles. It's supposed to be scaling because all the sides are different.
Okay, so Marina was saying that the student understood that that is a right triangle, but didn't understand which part?
That it was an isosceles.
That it was isosceles, or that it wasn't isosceles? Was not isosceles. Okay. What else, Juju?
They didn't understand that not all of them should be, not all of the triangles should be in a different spot. Like the first one is in scalene, the other is isosceles, and the other is in equilateral when they're all the same triangle.
So you're saying that they didn't understand that it should be just in one place and they put it, okay. You know what, I did have some students from a different class who did put triangle 1 in 3 different places, but this was actually 3 different students. But you're right, that is a misunderstanding that 4th graders commonly make, is they don't understand that it can only be one thing.
It shouldn't be an equilateral because none of the sides are equal, but all of them, they all are right. So it's placed correctly on right, but it's not placed correctly on the sides for isosceles and equilateral.
Okay, so it's correct that it's right, but it's not correct for isosceles and equilateral. We'll take one more comment. I know, Max, you've been dying, so why don't you add one more thing?
So I'm kind of saying what Tanae said. So an equilateral has to have all sides equal, and that triangle we can see that doesn't have all sides equal because its bottom is way smaller than all of its other sides. So it can be either equilateral or isosceles because well, all of the sides are different, they're different length, and isosceles has to have two sides same length, and none of those are same length, so it has to be scalene.
And I've heard a number of you repeat that or say something similar, that it has to be scalene. Is that right? Yes. So is this one the right one?
Yes.
Okay, so I'll take these two down. Does that make you feel better when I take the wrong ones down? Yes. Yeah, okay. I'll just stick those there for now.
Here's another activity I used to do with my students. We would create a classification for quadrilaterals. We would begin with defining the category of all quadrilaterals. What do they have in common? Next, I would ask, how are these quadrilaterals, all trapezoids, different from these quadrilaterals? How would we define this new next subcategory of quadrilaterals? Of all of these shapes have at least one pair of parallel lines. Then we do the same with the next subcategory. This builds a hierarchy of quadrilaterals, and students can see the relationships between categories. Certain categories are subcategories of other shapes. For example, students can reason that all rectangles are parallelograms because they have two opposite parallel congruent sides. Attributes that belong to a given category also belong to subcategories of that category. From here, we could generate conjecture statements. For example, a student might say, rectangles are sometimes squares. Is that statement true or false? Or all rhombuses are trapezoids. Is that true or false? Students would have great discussions proving their ideas. You can also do the same classification activity with triangles. Here's some general instructional ideas to keep in mind as you plan activities for your classroom. Take a minute to read through these ideas. Keep the focus on describing and classifying shapes and identifying classes and subclasses and relationships by using lots of examples and non-examples. This will develop a firm understanding of the properties beyond the simple identification tasks, and trust that vocabulary will grow from meaningful experiences. You can encourage the making and testing of conjectures by using the words all, some, if, then, what, if. Place these on your math word wall so that students have a resource to develop their ideas. Early on, children begin to use positional words to describe the location of places and the positions of objects, using sentences like, the ball is across the street, or my friend's house is at the intersection of these two streets. When we read a map, we are identifying a route from point A to point B. Using a coordinate grid is a way to locate the place and position of an object. Using a coordinate system helps students think about the distance, direction, and location of objects while further developing spatial reasoning. This slide shows an introductory lesson using shapes to learn about location and the XY coordinates. Question D is asking students to determine the distance and direction of shapes by focusing on the terms and units and axes. In 5th grade, it's important that students develop all these different ideas using the coordinate system. Eventually, students use their knowledge of geometry, measurement, and algebra with coordinate grids as they become more sophisticated with the use of coordinates and numbers. Here's another activity to help students make observations about using the coordinate grid involving movement from one point to another. Take a second and read through these directions. Press play when you're ready to go. This type of activity requires more thinking and reasoning when using the coordinate system, not just identifying the location of points. The collection of geometric experiences you provide are the single most important factor in moving students up the developmental ladder. The progression in geometry is different than number development. In working with numbers, the number sets get more complex as the grades progress. Yet in geometry, grades K through 8 use geometric shapes in many ways. The students' interactions with shapes become deeper and more extensive as new vocabulary is introduced and layered into experiences. A student's cognitive framework becomes more refined when discussing and reasoning about shapes at deeper levels. Their thinking moves from generally describing shapes to becoming more analytical about properties, thinking about a shape and recognizing it by the properties it has. For example, a square has 4 equal sides and 4 right angles. Some combinations of properties include some shapes and some do not. And finally, students have the ability to think of abstract geometric concepts and are able to see relationships between classes of figures, beginning to use informal logic reasoning. They understand that any property of a category also applies to all shapes in its subcategories. For example, a student can reason that a square is a rectangle because it has all the properties of rectangles. And as mentioned previously in upper grades, many strands of math, including geometry, measurement, and algebra, come together as students work with using more complex coordinate systems in transformations and graphing. Here's a recap of our learning targets. Press pause and read through these and think about if you feel like you've met these targets.